Hey, Sam.
What is this?
Let's find out.
Oh, we're coming for you. Got some learning to do. No, we don't know Kung Fu, cause we're science ninjas. Woo! Science!
Hey, Darren.
Hey, Sam.
I would love to bring slime into my science classroom because the kids, they love it. They love
course.
slime. But I want to know, how do I make the best slime from an expert such as yourself? One that maybe isn't super messy. And also, what can I teach with slime?
Well, Sam and Science Ninjas out there, we have the perfect, coolest recipe for super slime for you and your students and your fellow Science Ninjas. And we're gonna use this super awesome recipe, which is very clean but super fun, to teach your students about the kinetic molecular theory and states of matter. Let's do this. Slime time, it's slime time.
How difficult will it be to prep this demo?
Well, prep-wise, this demo is going to be okay. You just have to prep some glue solution and borax solution, have a container to hold it. It's going to be fairly easy. It's afterwards, the cleanup, that you really got to think about. You got to be thinking about how are we going to be getting our kids to be cleaning up all that slime. And don't get me started on what happens if it gets on pets or your clothing. It's going to be very difficult to get out.
So if we can do it right, we can probably make it moderately high.
Yes,
How safe is this demo?
extremely safe. Borax and glue, household chemicals.
How excited will the kids be?
Well, you tell me, how did you feel about making some slime?
Pretty excited.
Bingo. And that's why you and your kids are going to be Science Ninjas.
To make some slime, you'll need 600 milliliters of glue with PVA in it, 300 milliliters of water, and a stirring rod, some food coloring, any color will do, a scale, which can be used to measure out 40 grams of borax, 2 liters of warm water, a measuring cup, large plastic cups, and some plastic bags. It's time for
Safety Suit Up!
Very nice, but again, wrong suit. Much better.
We're going to make some slime. If your students have a bit of an allergy or they're not really feeling the texture of slime, you can glove up. Latex free, generally a good choice. But if you also don't have gloves, there's nothing really in slime that we're making that's going to be harmful to them. It's just basically the same level as like laundry detergent and glue. And then lastly, when you're dealing with chemicals, eye protection is always a good thing. That being said, there's nothing really here that's going to particularly harm your kids, so it's kind of optional. It just really depends on how much you trust your kids not to sting their eyeballs. Okay?
Touching your eyeball after touching slime.
Wink, wink.
Probably not a good idea.
Not a good idea. Okay, so we're going to make 2 solutions before we make a slime, okay? First one is the glue solution. So we are going to need to get some glue, specifically 600 milliliters of glue. Now I notice you got the Amazon glue. I have the good old-fashioned Elmer's glue that I grew up with.
What's the difference?
And yeah, this is Amazon. They're actually the same. The key thing we're looking for is long as your no-name glue has PVA, polyvinyl acetate, you're going to be doing fine. This is more expensive. Amazon link below. Much cheaper. So what do you want to make with first?
Let's try the budget-friendly version.
Yeah. We're going to start with a container where you're going to measure out 600 of that glue. So you pour, I'll tell you when to stop, okay? So we're going to go to that line there. Ooh, glue.
You will need 300 milliliters of water, which will mix with the glue to make your solution. Use a stirring rod to combine the glue and water.
Don't lick it.
Get the sides, and just really
There
whip
you go.
that so it's consistent.
Add food coloring to give your slime some fun colors.
So we're doing that. So now we're going to make our solution, powder solution.
The borax solution will need approximately 2 liters of water and 40 grams of borax.
Notice this has to be warm. Why?
It could be cold, but if you want the borax to really dissolve well, hot water's best. Just like when you're preparing your favorite hot chocolate or iced tea, you always start warm. The kinetic molecular theory actually explains that. When things are hot, there's more space between the molecules to accept the solute that you're dissolving. Okay?
All right.
Okay.
Shall we add it?
Yeah, so we're going to grab some borax, 38 grams to approximately 2 liters of water. Yep.
Okay.
So give it a stir. Now we have our 2 little solutions, and make sure there's no chunkies at the bottom. Yeah, we're going to put this on the side here for a moment, and then you're going to pour yourself approximately 200 milliliters.
So I gotta go to that one.
You know what? You can go to 3. This
Three?
is where we're eyeballing things.
Okay.
So that has to be precise.
But how much you use?
It's
Okay.
pretty cool. Okay, so now what we're going to do is we're going to get our glue solution. I'm going to pour it in here. So I would strongly recommend that you have yourself a nice little bucket that can catch. It doesn't have to be a cool square bucket like this one, but you definitely want a bucket. And do you see how you really did a great job?
Yeah, I did. The outside looked stripy, but the inside was totally mixed.
Now this is where the money comes in, okay? So here we have very liquid glue, and then I'm going to ask you to liberally splash it through. Okay, all the way through, very nice, okay? And then get your hands in it and look at the polymerization. It's instant.
Ew.
Ooh, so nice. And now
It's snotty.
Yeah.
Wow, that was like immediate.
yeah.
Immediately just,
Now the key thing here, what we're
it
doing,
was glue
Sam,
and now it's not.
yeah, is we gotta get all that glue polymerized. So we're gonna keep mixing through, and then if it's still a little sort of gluey, we can add a little bit more of the borax water. So you wanna go ahead and do that?
Yes.
So we're gonna totally make everything gross, and that's okay. Let me kind of de-slime you a bit. Just get a little bit more. And you can just do a splash of it, it's okay. Yeah,
A little bit.
a little bit more. Yeah, okay. And the key is we're just trying to get that, yeah. there
Oh
you go.
my God.
Yeah, you're trying to knead it, okay? Now this is what we would call sticky slime. If you want your slime less sticky, then you're going to add a little bit more borax to your solution.
Okay, so just keep adding.
We did about 40 grams to 2 liters of water. You might try maybe 42 grams, just a little bit. It's
a fun little experimentation.
Yeah, the big thing that kind of messes people up is they add too much borax. Now here, we're actually making very sticky slime, and I'm going to try to rescue this. I'm going to do the same. Our poor little bucket is toast. Okay, and I'm going to quite liberally, and what I'm trying to do is polymerize.
More polymer.
Okay, so we're trying to connect all those molecules together using the borax, and it's definitely starting to go
It's
where we
eating
want.
my gloves.
Yeah, it's eating my gloves, and I'll be honest, you want to go gloves off?
Yeah.
Yeah, let's go
So
gloves
it's time for gloves off.
Okay, now clothing protection. Your clothes are not going to react very well to this.
Well, what happened?
Oh, you get this on your nice cotton sweater there, it's going to be quite hard to get off. But this is actually getting very good. So you notice how over time it's becoming more putty-like. You can feel it's quite good, and you notice it's less sticky now?
It's less sticky.
Yeah, so now we're gonna do something kind of weird and gross, is make sure when you're doing this, that you're doing this on a table that it doesn't have any cloth on it, like a metal
Right.
table, even a wood table's okay.
Oh, okay.
Classroom table, perfect, like a plastic
Yeah,
table.
They're kind of built for these.
Yeah, and we're gonna take this out, okay? And you'll notice that we have a lot of extra slime that's stuck. A little trick I've actually learned, and this is for you teachers out there, if you don't want a huge cleanup, you can actually pre-oil your container. So
Oh,
if you add a
oil.
bit of vegetable oil before, it creates like a little barrier from sticking.
It is like cooking.
Yeah, it's totally like cooking. Cooking is actually a very special form of chemistry, right? All right, so we got that. We're gonna lose that over there. Just put it underneath. All right, and this is the fun part. So you're gonna get the kids to play with this and try to get rid of some of the moisture because we've added quite a lot of water. Okay, and in the Science Ninja classroom, we're not afraid to make messes. We just clean them up after.
I like that.
Yeah. What we have here easily could be 4 kids. You can see that, right? So if this recipe is for 4, you would multiply the recipe we did by 7 or 8 to make a class set,
Right.
right? Now, if you really want to make a class set then and make it kid-friendly, because I don't think you want them pouring big jugs of glue and big jugs of water, okay? You could pre-measure it where a cup like this, where you would go to your favorite coffee shop, you tell them, hey, I want to do a science experiment. Would you be willing to give me 20 large plastic cups? They've never said no to me so far. They're very, very nice, okay?
That's such a good tip.
Yeah, so you just get the cups, and then this amount here, which is, 3/4 of a large cup, that would serve 2 students.
Okay.
So, right?
So a pair to
Yeah,
use.
so
then
if
you
you
only
had
have to pour.
so you had about 15 cups, okay? Or 7 times the original recipe or 8 times the original recipe, you got it made. So imagine a classroom full of these cups and the black bins together, you're gold. And then you control the borax bottle.
Ah, so the teacher comes around and pours.
Yeah, and pours it in.
Yeah, and then kind of decides when to stop.
Yeah, okay? And that way you have control, and then these are recyclable, and so you don't even have to throw it away. I just get the kids to rinse it out and then use it again.
So the kids are mixing their own colors.
Yes.
While this is
Yeah,
happening.
so this is just good old white, but they could make their own colors, right?
Like this beautiful purple.
Yeah, this is awesome. If you do end up getting it in a place you don't want it to be, if you add lots of this directly on the surface, it'll start to over polymerize it and make it easier to get rid of what you need. Oh man, this is so good! Woo! Loving it.
Let's drop it at the same time.
1,
2,
2, 3. Oh, this is amazing. Now, you want to do some tricks?
Okay.
Yeah?
Teach me some tricks.
I'll teach you some tricks. I'm gonna give you a choice here of fun things you can do with your
Okay.
non-Newtonian fluid, okay? So option 1 is we can make some fun, silly noises with the slime.
Okay.
Or we could use the hot air within us, and I have a lot of that, and we can use it to do something with the slime. What do you want to do?
I want to do the hot air. What does that mean?
Okay, so watch this. I'll show it to you first, and then you go ahead and do it. So you get your slime, you're gonna put it on your table, you're gonna put it right at the edge, and you're gonna make it really, 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 really flat. Then you're gonna get your straw, and with the global pandemic and whatnot, you'll want separate straws, okay? I actually find plastic straws work a little better than the paper ones, but with environmental considerations, paper can work too. You're gonna stick that straw underneath, you're gonna make it really, really flat, you're gonna get really low to the thing, and then, remember I said it was full of hot air?
Whoa!
Well, my bubble's full of hot air now.
I'm ready.
Are you ready to woo? And
Does
it's-
it pop?
Yeah, it pops. And look, it doesn't really stick to you forever.
I'm gonna see if I can get this to work.
Okay, you want to trap the air with your hands, yeah?
Oh gosh, this is harder than I look.
Oh, a nice handprint there. There you go. There. You're full of hot air too, but in all the best ways. Look at that. That's terrific. Look at how big your bubble is.
my nose.
Look at how big.
Gross.
Yep. So
Ew.
inevitably you have to pop your bubble, but man, is it fun to do that. Now you notice with the paper straws, the texture of the paper seems to make it stick a little more, but it's definitely doable. So demo 2 you can do with slime involves somewhat silly noises. You ever heard that song the kids sometimes sing? Beans, beans, the magical fruit.
The more you eat,
The more you toot, the more you toot, the better you feel.
So eat some beans at every meal.
Well, in this case, if you're beanless, like I am, but you got lots of slime, you can show your love for beans, okay? So you're gonna get a cup. I'm just gonna use my beaker here, but IKEA cup, plastic cup works. You're gonna grab a chunk of slime, then you're going to put it loosely in the cup, okay? And then put your fingers in and, oh, I'm so sorry.
That was such a good one.
I'm so sorry. Oh, excuse yourself, young lady.
Excuse me.
Now, if you want a
is my
really good
butter.
fart, or a good silly noise, as I like to call it, you're just gonna kind of put it on top, really loose, like where it's draped over top. Yep, like so, and then, oh, sorry. Oh. Another fun demo you can do is literally what Sam's doing right now, is see how far you can get it to stretch in one piece, okay, without breaking. I've had kids go to the second floor of our building and then stretch it almost to the first floor. It's pretty amazing.
That's crazy.
Yeah, and that's the power of a non-Newtonian fluid, right?
Well, this is super fun. Like, what am I teaching with this in science class?
Well, you can teach a couple of things. You could definitely teach, for example, the scientific method, where they could do different experiments with this and they change just one variable at a time. But a fun concept I love to teach with this is the kinetic molecular theory.
Ah, the KMT.
Yeah, the KMT. Yeah, you know me!
I'm familiar.
Yeah, so you remember the KMT?
I do remember.
Yeah.
It's one of the first things. Do you want, I could try to explain it with a couple of my closest friends.
Ooh, good idea. Ninja time.
All right, so the kinetic molecular theory, also known as a KMT, outlines the properties of the 3 states of matter. With my closest friends here, we are displaying what molecules look like in a solid state of matter. You could say that there is a refined nature to the way these molecules vibrate or bob in place, much like how someone might appreciate a piece of classical music. Molecules in a solid are close together and hold their shape even when they are cut. On the other hand, liquid molecules are a little more spread out and less rigid than those of a solid, but instead of bobbing, they like to slide around. Notice how they slip past one another, like people enjoying an indie rock concert. The thing about liquids is that they take the shape of any container that they're in, such as this circle, this triangle, and whatever shape this is. Now, gas molecules are the most spread out. They're the party ones. They have the highest amount of energy between the 3 states. They move more quickly and do their own thing, bouncing off one another. One major difference between liquids and gases is that they can expand and compress to fill whatever container they're placed in.
You have some pretty cool friends.
Thanks. What did you think?
I thought that was a pretty cool way to learn about the KMT, but now using your knowledge of the KMT, the kinetic molecular theory, what exactly is slime? Is it a solid, a liquid, or a gas, or maybe something else? What do you think? Why don't we borrow your 10 friends again?
Our friends are currently modeling how glue molecules behave. As a polymer, molecules group together and form something that looks like little conga lines. This makes for a pretty wild party. But when we add borax, which are represented by our friends in the orange chairs, they form crosslinks between the polymer conga lines, bringing the party down just a little bit. And with our crosslinks formed, we now have a more organized party, where the polymer chains are stuck together, which gives us the unique properties of slime.
That was so cool.
How do you run so fast up these stairs? Oh my goodness.
You good?
Yeah, I'm good.
Well, I just learned that the borax reacts with the polymers in the glue to cross-link them and turn that sticky glue stuff into this pourable, breakable, non-Newtonian fluid.
Yep.
That's so cool.
So then back to the original question. What state of matter is this? Ask your kids that, and your answer is, well, actually none of them. It has the properties of a solid. See, you're ripping it apart, and solids can be broken into pieces. But it also has the properties of a liquid. It can be poured. So here you see I'm definitely pouring it out of my container.
Very slowly.
Very slowly. And the reason why it's pouring so slowly is those cross links you talked about.
Yeah.
So the glue is made of long chains of molecules called polymers, and the special chemical that's reacting is the PVA in it, the polyvinyl acetate.
Polyvinyl acetate.
So that borax cross-links or connects all those polyvinyl acetate polymers together, and it forms this in-between sort of piece of matter between solid and liquid, like what you called was a non-Newtonian fluid, which is sort of like the rebel fluid. It doesn't play by Newtonian physics.
PVA, polyvinyl acetate.
Yeah.
Isn't that great?
Cross-linked by borax. Cool.
I feel like that could be a really good song in that.
You're saying that you had a good time with the slime?
I had a great time with slime. I'm feeling fine.
You're feeling fine? Are you feeling time for, it's, okay, that's not
Roll the tape.
It's time for what? It's time for what now? Everybody's feeling fine and making some slime. It's time for what? It's time for what now? It's a solid and a liquid at the same time. Here's a recap of the KMT, kinetic molecular theory. Solids are the lowest energy state. They keep the shape and the pieces break, while liquid molecules wanna slide. They'll take any shape that they're inside, but catch that beat, add some heat, then you'll have to take a window seat. Watch them fly free, they like to party. Gas molecules have the highest energy. Not only will they take any shape, but they can be compressed into a smaller space. They move everywhere, trying to spread out. That's what the KMT says it's all about. So there you go, 3 states of matter. Get ready for your brain to shatter. It's time for what? It's time for what now? Everybody's feeling fine and making some slime. It's time for what? It's time for what now? It's a solid and a liquid at the same time.
So what's the deal with this thing called slime? Like liquid and a solid at the same time? Has to do with the glue's PVA.
Polyvinyl acetate.
Chemistry formula, my chem people say C4, H6, and O2 make long chains. Get super sticky, polymer tricky. Got more atoms than your favorite wiki. But wait!
One more chem to contemplate.
Borax comes in to join the chains, covalently bonding for cross-linking. Slime is blending the KMT with its non-Newtonian fluid chemistry.
It's time for what? It's time for what now? Everybody's feeling fine and making some slime. It's time for what? It's time for what now? It's a solid and a liquid at the same time.
Ooh, that was a slimy, rhymey time.
Yep, and I think for this slimy, rhymey time, it's middle-aged slime time, nap time for this guy.
Well, if you like this video, please like, subscribe, and hit that bell notification below so you don't miss another.
And if you really like this video, make sure you consider sharing this video with another cool teacher just like you.
Well, I'm Sam.
And I'm still Darren.
Till next time, keep being a science ninja in your classroom.
It's time for what? It's time for what now? Everybody's feeling fine and making some slime. It's time for what? It's time for what now? It's a solid and a liquid at the same time. Here's a recap of the KMT, kinetic molecular.
Okay.
You people!